Hi, I'm Elizabeth Krukowski. I'm a senior geoscientist here at Premier. I work with the Core Services Group, specifically the Special Core Analysis Lab group. Now, within that group, we specialize on looking at unconventional resources or unconventional rocks. Now, part of the protocol that we have here at Premier is something called our Unconventional Workflow. That unconventional workflow takes these tight shale-type rocks, and we want to get you the best quality data. So we want to get you the best answer for porosity and permeability for these samples. Now, in order to do that, our unconventional workflow takes a few approaches that have been developed in a research lab that we're using now for commercial purposes. The first is we very carefully take the plug sample out of the core because very easily, a lot of these unconventional samples will start to poker chip when you plug them. It can be very difficult to get a solid plug out. Now, to ensure that that plug is solid, the first thing that we then do is we put it in our micro CT, which is actually right there. And then we can go in and we can see if there are any fractures in the sample that might give us any questions about our permeability data later on. From the micro CT, the samples then go to an as-received NMR. Now, unconventional samples are a little bit different. If you've even looked at a shale, you know you're not going to clean it. So with a conventional sample, typically you're going to clean the sample before you NMR. We're never going to get all the stuff out of the unconventional in a reasonable amount of time. So we do an as-received NMR to see what is in the sample when we first get it. From there, we then pressure saturate with a light oil at temperature. Then we go ahead and do another NMR. So we're assuming at this point that the plug is all filled, all the porosity is full with this light oil that we can then detect in the NMR. Then we have our total fluid volume from the NMR. Now, to get the porosity, we do bulk volume and we measure it a couple of different ways. And then once we're confident in that bulk volume, we can calculate the porosity via NMR. Now, once the NMR is completed, then we go ahead and we'll do a permeability measurement. Now, we do this a little bit differently. We do it at a steady state permeability with a constant rate because we have these pumps that are optimized to flow at very low flow rates through these very tight rocks. And this ends up with us being able to measure into a nanodarcy range flow. And then typically after the samples are done with our flow experiment, which only takes about 5 days, give or take, then we could go ahead and clean them and then we'll try to confirm our NMR saturations and our NMR fluids in the Dean Stark as well. So this way we're actually QCing our data as we go, and we want to make sure we give you the most accurate value for your porosity and permeability. So in the end, we're adding value to our clients' data by being able to give them some confidence in their porosities and in their permeabilities that they can then use in their workflow. Now, something else that we can do that's a little bit unique, that's a little near and dear to my heart, is Raman spectroscopy. So we have a Raman microscope that is capable of taking a thin section sample and looking at it and then doing a mineralogical map. Now, the Raman is looking at these chemical vibrations, and I'm very complimentary to SEM in the fact that you could take a Raman sample and get it ready as you would for SEM, and then do a map over it with the Raman, give you an idea of the chemistry, spatial chemistry, where are your minerals, where are they in relation to each other. Then you code it, do that same sample in SEM, and you're able to get your elemental from the EDS as well as just getting a textural information from the SEM as well. So being able to take that sample and look at it from the pore space all the way up to plug space, and then being able to back calculate that data and give that to our clients for reservoir formation information.